of Broad Indian Society of Remote Sensing, which has more than 5,000 professional participation, as well as the purpose of Indian Society of Remote Sensing is to propagate and inform the society in large and give large amount of outreach program about the space as well as remote sensing capabilities of India in terms of providing societal benefits. So I am sure IMS is also doing the similar job, but from meteorological point of view. So as far as the Dehradun chapter activity is concerned, we are really focused in these part of Uttarakhand, Dehradun and surrounding cities. We have a good number of members as well as student members, and we seek large amount of members, especially from student community, those who are very eager to know about how the space technology is being used for various applications. So this particular series is especially meant for youth, which are the future of our country, and to develop a scientifically thinking society, it is important to propagate the message of science and technology among the young generation. So with this thought, we have brought out this particular event to you, and I am sure all the participants will get immensely benefited from the rich and vast experience of both our speakers, Dr. C.M. Chandramohan Kishtawalji, as well as our second speaker next week, Dr. Arijit Roy. With these words, I would once again welcome you all and and extend my thank you to Dr. Kishtawal for accepting our invitation and joining us today on this occasion to deliver a very nice and important talk on weather and climate observations and prediction. Thank you everyone. Thanks.
Thank you so much.
Thank you, sir. Now I request Dr. Vikram Singh, Director IMD Dehradun and Chairman IMS-DC, to give introduction of IMS-DC.
Yeah, thank you, Madam. Good afternoon, everyone. First of all, I welcome all the students and their teachers on behalf of IMS-DC. I welcome prominent scientist Dr. C.M. Kishtawal, former scientist SAC Ahmedabad, for agreeing to deliver this lecture. I also welcome Dr. Prakash Chauhan, Director IIRS and Chairman ISRC-DC. As mentioned by Dr. Chauhan, Director IIRS, IMS-DC and ISRC-DC, in collaboration with IRS, is organizing an online lecture series today on 4th December 2020 and again on December 10, 2020 on the behest of Youth Climate Day, Action Day. Youth are at the forefront for raising their voice to implement substantial measures for climate change. They are demanding actions globally to mitigate the impacts of climate change. Hence, this lecture series aims to sensitize and involve youth of today to understand climate change and its implications on society. IMS Dehradun chapter has been constituted in April 2012. Soon after its formation, the chapter initiated live membership drive in various government and scientific institutions in and around Dehradun. It has around 84 live members in short span of time. The chapter regularly organizes events, lectures, workshops on various days of importance such as World Meteorological Day, Earth Day, Ozone Day, Environment Day, etc. Besides, the chapter has organized 3 important workshops in the past and short courses. And among these, most important were TropMet 2012, this national symposium on frontiers of meteorology with a special reference to the Himalayas. And second was a special course on geoinformatics for meteorology and climatology applications during November 18 to 29, 2013. And a special course on satellite meteorological observations and products for agrometeorological applications was organized during December 1 to 5, 2014. And number of lectures, as mentioned, are being organized for the benefit of the young students and teachers and scientists. So with this, the election of this council was held in 2020, and current executive council is fourth one in the series, and it has 6 members for the term 2022-22. In September 2020, IMS-DC organized an online talk by Professor Shyamlal, Honorary Professor, Physical Research Laboratory, Ahmedabad, on the occasion of World Ozone Day. The lecture was received enthusiastically India-wide. So I once again welcome you all, and I'm sure that this lecture by Dr. C.M. Kistwal will highly benefit the students and participants from various institutions. Thank you. Namaskar.
Thank you, sir. Now I request Ms. Asfa Siddiqui, Secretary, ISRC-DC, to introduce our beloved, well-known speaker, Dr. C.M. Kistwal.
Thank you, Pooja ma'am. This is indeed an honor to be introducing the speaker for today, Dr. C.M. Kistwal. Sir superannuated as Outstanding Scientist and Group Director, Atmospheric Oceanic Sciences Groups from SAC Ahmedabad. Dr. Kistwal received his master's degree in physics with specialization in astrophysics from Kumaon University, Nainital in 1983. He joined ISRO in 1984 and have completed his PhD from Indian Institute of Technology, Delhi in 1994. His research interests include the development of techniques for operational prediction of tropical cyclones using satellite observations, monsoon prediction, operational retrieval of cloud motion winds from satellite observations, and impact of land surface processes on weather and climate, particularly the impact of agricultural intensification and urbanization. During 1998-99 period, he was research associate in Florida State University, USA, where he worked towards the development of multi-model ensemble technique for improvement of weather prediction on medium range to seasonal timescales. During 2009 and 10, he was a visiting scientist at Purdue University, USA, where he worked on operational and theoretical aspects of land surface atmosphere interaction processes. He has also contributed as the project director of InSat 3D data utilization for science and applications in Indian Space Research Organization. So with this brief introduction, I please request Dr. Kistwal to please take over and start the lecture. Thank you, sir.
Thank you, Dr. Prakash, Dr. Vikram Singh, Dr. Pooja, Shama, ISRS Dehradun and the IMS Dehradun chapter for giving me this opportunity. First of all, let me convey my best wishes to you in this time of pandemic for your good health and for you and your family. You please stay safe, and just because this is a very pandemic phase worldwide, so we have to bear with that. With this, I must thank all of you to giving me this opportunity. So this is, let me just start my talk. I may not be having many slides, but you have to, you can ask any question if you have, and I'll be very glad to answer those questions. So basically, what is how we define as the weather? Actually, everybody knows, and we all know that what is the weather and what is a climate. So weather is basically the state of the atmosphere at any given point of time. So someday the weather can be very sunny, some kind of partly sunny, or maybe stormy, cloudy, rainy. That's how we define the weather. And it is a very common, very normal thing for us to think about the weather, because we don't see anything unusual or anything very specific in that. And what is the climate? Basically, climate is the average state of weather. So if you say that Dehradun climate is very cold, so it means on average that Dehradun is a cold place. But on some day it can be very hot also. But in general, it is so climate is a general state of the atmosphere at any given place. So that is what is a very simple definition of weather and climate. So then why we have to bother about the weather, and why we have to bother about the climate? So if it is so day-to-day thing for us, so why we have to really bother about it? So So basically, there are very different climatic zones in India. This picture shows approximately 30 climate zones, 30 climate types. So, India is most part is basically the monsoon driven, and some part of India is basically comes in the desert, like the Thar Desert and the Rajasthan parts of area, and adjoining Pakistan, Iran, and parts of Africa. They all come in different similar climatic zone. Then we also have evergreen forests, tropical forests, and very different kind of systems are there. So this is quite a state of the climate right now. But this weather and climate has, in particular in the recent times, it has assumed a very important role in our society. And not only today, it has been a very important part of our lives and our civilizations and our history. And there are many occasions when this weather and climate has changed the course of history and the civilizations. And there are several books on that. There are several books on that. And you can see that there is a famous book is called The Long Summer. If you see the graph below this book title, you can see that the earth was a very, very cold place once upon a time. It was an extremely cold place. It's very difficult to survive, very difficult to even think of doing some agriculture, having a society. So that time the human civilizations were basically confined to their own caves, and they were mostly depending upon the hunting. But slowly and suddenly the temperature of the atmosphere increased. And then it increased for a very long time. Actually, the temperature of Earth 8,000 years ago was much warmer compared to even today. So today, even after the global warming, the temperature is nothing compared to what we had 8,000 years from 8,000 before today. So that is they call the long summer. And then the long summer is basically, this was the time when people migrated, because some of the parts of Africa and other continents became very hot, and then the people started migrating to more safer and colder places. And then it changed the complete course of civilization. Its complete course of civilization was changed because of that. Then there was a lot of flooding in the tropical Africa, and then people migrated from there to Africa. And like that, the climate had changed and shaped the way we live today, and then what we are today. So we have been completely shaped by the climate change. And climate change is inevitable. It is a very important part of our system. It is an important part of our society, our ecosystem. The change is inevitable. It is bound to happen. Some changes are man-made, some changes are natural, but the changes are always there. Then we can see a graph below the second book. You can see that this is the history for past 4,500 years. And you can see that even in this short period, the Earth has seen a very dramatic changes in the Earth's temperature. There was times when the Earth was very, very hot. Sometimes it was very, very cold. And it completely changed the way people live and work in their lives. That's very important. And the third thing is that it is not related to climate, it is related to weather. And the many weather events have changed the course of history. I'll show you some example from India also, but this is the graph. If you can see the graph below that third book, that is the graph. It was this type of graph was first generated in 1860. So it shows how the Napoleon's army marched in 1812 to Moscow. And that time, that season of the winter was extremely harsh. Suddenly the temperature was below 40 degree, below minus 40, minus 60 degree. And if you see in the beginning, they started with the army of around 4 lakhs. And ultimately when they returned, if you see the dark side of that, it is the time when they started coming back, because the weather conditions were very harsh for them. So by that time, their army was reduced from 4 lakh to just 1 lakh. And then when they came back, only 10,000 soldiers could come back. So that was the situation of the weather, and it has completely changed the course of history, because otherwise, if this winter event would not have happened, the history of the world would have been different than what is today. Now, this is another example from India. when Babar invaded India, and there was a decisive battle between Babar and Ibrahim Lodhi in the Battle of Panipat, that happened in 21st April 1526. What was the important part of this war was that the Babar's army was equipped with the artillery, that the guns and big guns and cannons, and they choose the time of war as the April, when it is completely dry situation over the North India. So that it was very favorable for them because their gunpowders were very effective in the dry situations. So if this war was postponed by just 2 months, if they could have postponed, the Indian people have known about the weather and they could have known their strategy, and if they could have postponed this war by just till July, then it would have been rainy season, and then all the artillery and gunpowder would have been ineffective, and this could have completely changed the outcome of the war. So this is how the weather information and weather has played a major role in defining our history also. This is another example when the weather changed the course of history, the birth of Bangladesh. The birth of Bangladesh happened because of a tropical cyclone. There was a devastating tropical cyclone in November 1970, and it killed close to 3 lakh to 5 lakh people, and it made a wide-scale devastation in Bangladesh. That time, Bangladesh was a part of Pakistan, and it was the main government was sitting in today's Pakistan, and it was very far from East Pakistan. So they could not, or they did not did a very good disaster management in that, and people were just crying and they were suffering, and there are so many dead bodies lying here and there, and there are so many pandemic situations are being created because of situations were not good, and there are so many people who are ill, who lost their everything, who lost their property, who lost their shelters, and there were no hospitals, and government was not doing anything. So basically what happened, that it created a revolt in the people, and they created a lot of protest. And because of that, the government of Pakistan started suppressing these East Pakistan people, and they started coming to India as refugees. So this became very, very serious problem for India, because so many refugees were coming to India because of the suppression by the government, and then India actively participated in this war, Bangladesh war, and then it became a free country. So this was probably the first country which was created due to a weather situation. So you can see that how important role a weather can make, and weather can actually it can create countries, and even the climate change is the similar thing, which is having a potential of having a big impact on the societies and our governments and our the relationship between different countries. So those kind of things are within the power of the climate change. Now in today's time, how we are using how in the modern times we are using the weather forecasting information, because weather forecasting has become very important part now. Everybody is using weather forecasting now for their benefit. For example, you can see when a cricket match starts, then people want to know that what will be the weather on that day. So it depends a lot. If the match there is a chances that the match will get cancelled, then people will simply not go there. And or how will be the pitch, and how will be the weather, how will be the humidity in the atmosphere. And then there is a tourism season. For example, in the winter season, people go to the Shimla or Mussoorie when there is a snowfall. So if somebody can predict the snowfall in advance, maybe some 20 days ahead, then there is it can make a lot of business sense to the people who are going there or who are operating hotels and the tourism industries there. So weather information can make a lot of difference in their lives. There are some examples like the weather situation over the sea. You can see the slide below, because I'm not able to operate my cursor. 1 minute. Sorry, but I'm not able to see my cursor. But you can see these pictures. Agriculture, it is making a lot of impact because people want to know how warm and how cold it will be. For example, in the cultivation of potato, if the soil is too warm, this potato cultivation does not go very well. Or if it is too wet, then they find it's very difficult to actually harvest the crop. So they want to know then when it will rain, how much it will rain, when it will not rain. So all these things make a lot of difference in the agriculture. Suppose for example in shopping malls, people suppose this winter, suppose it is going to be very harsh winter. So the shopping malls will take the preparation for additional winter wears, or maybe some, or suppose in the time of rainy season, they will keep arrangement for additional stock for the raincoats and the umbrellas. But if it doesn't rain, then nobody will buy those items, and they will incur a very big loss on that. Similarly, the disaster management, for example, in the tropical cyclones, and there is a big example of the frostbite in the horticulture, because if there is a very harsh winters and it freezes everything, there is a frost, then a lot of crop gets damaged. So this kind of damage can be prevented. It is not that it cannot be prevented. If you know in advance that the weather is going to be, what kind of weather you are going to expect, then you can make preparation for that. You can save a lot of agriculture yield. There are methods for preventing the frost bites and frost things. So similarly, there are a lot of wind energy and the solar energy companies nowadays, they want the forecast of the weather, because they have to plan for tomorrow's grid, then how much power will be coming from the solar energy and how much power will be coming from the wind energy. So, this is still in India, a lot of power is being generated by the thermal power. So, for thermal power, they have to burn a lot of coal. So if they know that tomorrow there is a lot of power is coming from the wind, so they will put less coal into their furnace, and they will save a lot of coal. But because once they put the coal, they cannot shut it down immediately. It takes huge time to shut down a thermal power plant. So if they know one day in advance or 2 days in advance that a lot of power is coming from the solar and a lot of power is coming from the wind, so they will accordingly plan the power management. So nowadays, n number of things, and the one item I forgot, that is the aviation. So this weather information is extremely important for the aircraft industry, aerospace and aircraft industries. All the airline businesses, they are heavily dependent on the weather situations, because when there is a thunderstorm in some airport, and you see the lots of congestion and the parking congestion and the lot of this havoc gets created in the airports, that you all might have experienced this thing. So if this kind of things are known in advance, then a lot of things can be planned. People, maybe some flight will start delayed. It can be delayed at the source itself, rather than waiting in the air. So similarly, there is a heat wave situations. So all these things there are many applications. Let me tell you, many applications. I have shown you very limited applications in this slide, but there are many applications which are affected directly by the weather forecasting. Now, if you see what are the hydrometeorological hazards and what is the cost of those hazards, you can see there are floods are there. Every year we see lots of flood in some city or other city, and people are stranded and they are got stuck up, and lots of train services get cancelled out, lot of flights get cancelled out. So the total cost of this is maybe hundreds of $billions actually worldwide, if you see. Then if you see this earthquake, of course, it's not a meteorological phenomena, tropical cyclones, droughts, extreme heat. So I think out of 6, there are 4 or 5 events, hydrometeorological hazards that are related to the weather. And it is estimated that you can prevent approximately 10% of all the losses if you know the weather forecast in advance. You cannot prevent everything, because if some rain is going to happen, it's going to happen. If something is going to destroy it, it will be destroyed. You cannot save everything, but you can save 10% of that. But 10% is also a very big thing, big amount. If you see it on the global scale, it turns out to be in the millions and trillions of dollars, or maybe rupees. Now, this is another example where the weather forecasting has made a very decisive impact is the tropical cyclones. And there is a very interesting aspect associated with the tropical cyclones that hit Bangladesh. That you can see within the circle that this is the topography and this is the morphology of the Sundarban Delta, and this changes every year actually, because every year there is a flood, and then they change the course of their flow, and these islands are created again. So there is not a permanent place where they can live, and this is a place of the Sundarban tigers actually. And this is also a place where lots of tropical cyclones are hitting, and if you take the 10 most deadliest cyclones that has hit the whole world at the world scale, the top 6 tropical cyclones have come into this area, and which has killed lakhs and lakhs of people in the past. So because of that, there is a major situation was created in the Sundarban area, is that the most of the tigers in that area were man-eaters. Why they were man-eaters? Because when there are lakhs and lakhs of people who are dying because of tropical cyclones, then there was ready meal available for the tigers in the form of human bodies, and then from the very beginning they were accustomed to the human blood or human flesh. So from the very childhood they were knowing that okay, human is the food. So because of the cyclones, now, and I'll see there is a book on that. There is called The Man-Eater Tigers of the Sundarban, and there is a documentary also in the YouTube, and you can see that documentary. And this is one of the many reasons that why the tigers become man-eater in Sundarban region is due to the heavy deaths due to tropical cyclones. And this is the history of tropical cyclones. You can see that most of the tropical cyclones, if you see the third column, fourth column, they are in the Bay of Bengal, everywhere. The lakhs and lakhs of deaths were created. They are the histories, the most notorious tropical cyclones, and most of them have occurred in the Bay of Bengal. But nowadays, because of the proper weather forecasting and the satellite observations, these people know very well in advance that a tropical cyclone is going to come, and now the death tolls have reduced substantially, very, very significantly. Now hardly, I think, that death toll goes in some tens or maybe 20, 30, maybe 100, but not lakhs and 2 lakhs or 5 lakhs, something like that. So this was a great impact, particularly over the Indian region, that the weather forecasting and the tropical cyclones, weather forecasting and satellite observations have made. Now, there are projections that how our global climate can change in future. So this is the weather forecasting. Now I talk about the climate forecasting. So what are the climate forecastings are there, and what kind of threats and what kind of opportunities they are creating? So you can see that the first big graph is showing the pictures of the temperature that has been projected for next 80-90 years. Now I'll tell you how we predict even so much in advance that what will happen in 2090 and 2099 by the turn of the century, what kind of temperature changes we can see. So you can see that the icon in the right hand side, and it shows that most of the parts of the India and northern hemisphere will be heated by as much as by 5 degrees or 6 degrees. So what will happen as a result of that? As a result of that, many countries will gain. For example, in Canada, it is very, very cold now, and it is very thinly populated, but those kind of warming will create opportunities for those kind of countries which many parts of the Canada and other Arctic circles, they are not suitable for agriculture at this point of time. But this kind of warming, they can become suddenly a hotspot for everything, because this will become very highly livable conditions over there. And if you see these small charts on the right hand side, these are the changes in the precipitation, and it shows that the precipitation in the West India is going to change for the positive. So, for example, if you take the case of the North Gujarat region, the groundwater has reduced drastically in the recent times. But this projection shows that it is going to rain very significantly more than what is raining now. So these kind of projections give an opportunity for people that they can invest on those areas for agriculture, because those places can become very much suitable for agriculture, and some other areas may become more dry and maybe not be so much suitable. So climate change will affect some things, some regions favorably, some regions unfavorably. But this information can make a lot of sense to many people who want to take advantage of this kind of climate change, or who want to prepare for the worst is going to come. For example, one of the aspects of climate change is related to the sea level rise. So many small island countries are facing the threat of being submerged completely. So they have to plan what they can do, where they can shift, or what kind of measures they can take to combat this kind of climate changes. Now, what are the major issues of the climate change in our time? Actually, this is one of the major issues is the global warming. So this is, as I told you, that it's a major issue also, as well as for some people it may be opportunity also. So this is the upper figure. It shows you that how much temperatures have changed in last 100 and 200 years. So now actually we are, in last 200 years, the temperatures have changed very drastically. And if you see the lower figure here, you can, this figure shows that how the Arctic ice has reduced. So you can see that what we see the Arctic ice today, it is only a fraction of what was there in 1980. And these changes have occurred only in the last 30 years. This is a very interesting diagram. It shows that how the temperatures have changed in different months. So this picture shows that in the month of December and in the month of January, particularly in the winter time, we are seeing more changes in the climate on the global average scale. This kind of temperature change is causing a drastic health problems for India also, because we are seeing more and more cases of heat waves. And you can see that in 2019, 2015, we had major heat waves, and you can see that the graph, the pink color graph that shows that how many events are occurring every year. And you can see that these events are, after 1980, these events are drastically increasing. So earlier there were only 3 or 4 heat wave events in India or in the globe. Now these events are in 24, 30, something like that. So this is a major concern, because the heat waves are a major health concern for everybody. In Europe, people are dying in thousands actually. Once upon a time, I think in 2015, I think 15,000 or 20,000 people in Europe died because of the heat wave event that lasted only 10 days. So because they are not accustomed to this kind of extreme temperature situations, particularly the old people whose systems are not so much built, and they are the older generation are the worst affected by these kind of climate changes. And particularly in India, we are not seeing so many deaths, but in Europe, it is a very devastating. This is the graph that shows in the France. In July 2006, 2,000 people died. In Russia, 2010, 55,000 people died actually. And in India, Pakistan, 3,700 people died in May 2015. So this outcomes of this kind of global warming are being realized now, and people are suffering because of this kind of extreme heat situation. And this on the right hand side, if you see the graph, this shows the number of heat wave related deaths in India. So you can see that from 1992, this graph is constantly increasing. In some years, like 95, there were some major events, but actually if you see, there is a completely growing trend in this picture. Another concern is the air quality, because there have been concerns in the air quality, and this is nowadays the major field of research, that how our air quality is increasing and how air quality is degrading, and what is happening. One major factor is basically the burning of like the stubble burning and the crop residual burning. When there is a crop is harvested, then the residual parts it is a waste, and then they burn it in the North India, and it is creating a huge problem for the air quality in India. So this is also a global concern, because of global climate change concern, because that is one of the things that affects directly our health. Now you see that in the Indian Ocean region, the tropical cyclones are also increasing. So if you see in the 2019, there have been 8 tropical cyclones in one season itself. There have been never actually. I have been working on tropical cyclones for quite a long time, and I have never seen this kind of season in my whole life. In 2019, one cyclone is completing, then another cyclone is starting at the same time. At one point of time, there are 3 cyclones. One is Bay of Bengal, 2 in Arabian Sea, something like that. So this is all the implications of the global warming. Cyclones are not bad for everybody. But for example, what the recent tropical cyclones, which is active in the Bay of Bengal, is giving plenty of rainfall to the Tamil Nadu. And Tamil Nadu people are actually getting a lot of rainfall due to this tropical cyclones. So tropical cyclones are doing good for some regions also, but by and large, it is a destructive thing. And tropical cyclone intensity is also increasing. And when the tropical cyclone intensity increases, for example, the maximum wind increases from 120 to 125, the damage potential increases as a cube of that. So just by, if you have 10% change in intensity, the damage potential becomes 2 times. So that is, the damage potential is basically much, much larger compared to the wind change. It is not directly proportional, it is a cube, proportional to the cube of the wind intensity. So this is, the growing intensity of tropical cyclones is a major concern because it has the potential to devastate several coastal areas if a major hurricane comes or major subtropical cyclone comes. So there are a lot of hazards related to that, like the wind hazards, and there are like a storm surge hazards, precipitation hazards. So all these things, and it is a very costly affair because you have to do a lot of evacuation and you have to do a lot of post landfall disaster management and disaster mitigation. All these things you have to do, and it costs a lot of money. So this climate change becomes a costly business because of this thing. And then another thing that is what we are seeing in the last several years is the changes of the extreme rainfall. Every year we are seeing the flood situations are increasing, and this graph you can see that the extreme and very extreme rainfall, extremely heavy and very heavy rainfall events are increasing in India. So there is a constant rise, particularly in the July. This faint curve is basically for the month of July, and the dark line is for the month of August. And you can see that they're constantly on the rise, and these extreme events are basically, these events are more dangerous than tropical cyclones. Because nowadays, tropical cyclones, people are not dying so much from tropical cyclones as they are dying from the flash floods and the lightning strikes and other things, because these flash floods come suddenly. We don't know the earlier warning of these events. Suddenly, you see in the morning it is very cool, very quiet, very sunny weather, and suddenly by afternoon, the weather changes and it becomes a very devastating storm, and it brings a lot of flood. So these kind of things are a big concern for the forecasting, that how we can predict these events very correctly and very accurately and very effectively, and we can disseminate this information so that people can take action. And you can see the small graph, this gray and blue graph, you can see the number of deaths because of the flash flood events in India. And this graph is constantly on the rise. This I have already told you, that how the tropical cyclone intensity is increasing. Oceans are also changing, that there is an ocean current system, and which basically transports a lot of water from the equator towards the pole side, and then it sinks. And when it sinks, it takes with it a lot of oxygen. And a lot of bioorganisms which living in the deep oceans are surviving based on this oxygen. Now some people say, and there are some studies, that this current system is getting slow. Why they're getting slow? Because this current system is basically driven by the temperature gradient, the temperature difference between what we see in the equator and what we see in the pole. But now the poles are becoming warmer, and equators are also getting warmer, but not by that much amount. So this difference is reducing. So this current system is getting weaker. So it has a lot of implication on the ecosystem, because if they get weaker, then there will be less oxygen transport to the deeper levels, and there are a lot of organisms which are living in the deep levels, they will be affected. Another is plastic pollution. You can see everybody is aware that how much plastic we are polluting the atmosphere and oceans with the plastics. And because of the increasing carbon dioxide, there is an ocean acidification. The oceans are becoming more acidic, actually. Acidicity is increasing. And what is the result of that? Due to this, the small organisms, which are basically called the mollusks and the other calcifiers, they are becoming smaller in size, because their situations for their survival are getting more difficult with the ocean acidification. So these are some glimpses of the climate change. So how we can actually predict, and what we are doing to predict this kind of climate changes, how we predict weather, how we model these kind of events. So basically, everything in science actually starts with observation. So first we observe some phenomena. So first of all, we should have a good observation network. We should have a facility to observe every phenomena, what is happening in the nature. If it is acidifying, how much it is acidifying. So we should have those kind of instruments. If it is this current system is weakening, how much it is weakening. So first of all, we should observe the system properly. Once we observe the system properly, then we have to understand the system, that why it is happening. We have a lot of science behind us. We know the laws of physics and laws of thermodynamics, laws of biology. So we can understand that why it is happening. Why these animals, why these small creatures are getting smaller in size. How they use the carbon dioxide, how they use the oxygen for their survival. So we have to understand that. We have to understand the physics of this current system. Then we have to understand what is happening in the biological part. And once we understand, then we attempt to predict it. So that is how this whole system works. The weather prediction and weather forecasting, climate forecasting. Everything is basically can be zeroed down into 3 terms. That is observe, understand, and predict. So what we are doing basically, and this Earth atmosphere system is actually a system of systems. There are many systems within that. There is a, you can see that there is a system, what we see as Earth, that we have the cloud, air, water mass, oceans, etc. After that, we have a ecosystem that's called the biospheric system, where there are a lot of trees, human beings, animals, plants, etc. And they are affecting the atmosphere. They are affecting the climate. They are also affecting the climate because they are adapting to the climate. They are absorbing the carbon dioxide from the atmosphere. They are releasing the atmosphere. They release the oxygen into the atmosphere. They also release the water vapor into the atmosphere. So they basically actively participating into defining our whole weather. Actually, the large rainforest like the African rainforest and the Amazonian rainforest, they are so vast and they are having so large impact on our atmosphere. They can change the atmosphere. They have their own weather. They can create their own weather. There is a research going on in this. There are some studies which shows that these forest systems, they can create their own rain if they want. So we have to understand it, how it happens, how their biology takes place, because they are intelligent creatures. Even plants are intelligent creatures. They understand that how much rainfall is there, how much the plants have become dry, how much is the moisture in the soil, and how much is the heat outside, how much is the carbon dioxide. Accordingly, they react and they change the ecosystem. So the atmosphere is not just clouds and the air and the water. It is made of the plants also. It's made of the hydrosphere, which is the water. It's made of the biosphere. It's a cryosphere. It is a big cryosphere means basically the part which is covered by ice. So it basically the Arctic and Antarctic and our Himalayas and many snow parts, they are part of the cryosphere. Then we have the geosphere. There are a lot of geology is taking place. Geology means how the interior of the Earth is behaving. And many of the climate change phenomena in the past have happened because of the geological region. There were big volcanic eruptions, and they erupted so much smoke into the atmosphere that the whole Earth was covered with the dense smoke for many, many years. And then it was a completely cold situation because the sunlight was not reaching to the ground, and then it was cold everywhere. And this cold remained for many, many years. So basically, geosphere is a very important part of the atmosphere and the whole climate system. So that's why it's called the system of systems. And they interact among each other. This is a complete holistic view, how they're interacting with each other. Even the wildfire, when the wildfire occurs, how it changes the atmosphere also. It has a lot of impact on the atmosphere also. Now, what kind of observations we are taking to, for example, measure what is happening at the surface? So basically, for that, there are automatic weather observatories are there, which measure how much is the temperature on the surface, what is the wind is blowing on the surface, what is the radiation, solar radiation, what is the wind direction, what is the humidity. And these are stations I think, there are several stations, such stations are mounted in different parts of India. It is nowadays very small weather stations are also available, which you can very quickly install. So there are many private companies, many government agencies, like IMD is a very big player in the installation of the AWS. ISRO has also installed many automatic weather stations. And this is a very big source of weather information for us. This is a very big source of weather information. But the limitation of this is that it is limited to the ground only. So we are not knowing what is happening at 1 kilometer or 2 kilometer height, which is very, very important. But it is nonetheless, it is a very important observation. And if I tell you that how much is the number of these kind of observations instruments, there are in many thousands. And this is the distribution of the surface observation network. There are approximately 10,000, but 10,000 which are basically coming under the government operated agencies. There are a lot of stations put up by the private players, and I think the total number must be more than 30,000-40,000. And nowadays there are, due to the basically the advancements in the technology, these stations are becoming very, very small. So you can carry with their hands and you can install it anywhere, and it gives you very accurate observations of temperature, humidity, etc. So you can see that in this figure, lots of ocean areas and the desert areas. If you see the deserts of maybe Africa desert, if you see the Africa, you can see there are very few stations over there. So we don't know what is happening over the Africa, what is the temperature over there, because those areas, nobody lives there. So it is very difficult to install instrument there, and there are a lot of winds are blowing, so someday your wind damage and you can be covered by dust also. So it is very difficult to maintain also. So there are a lot of gaps in oceans, and in the developing countries, like the poor countries, they don't have this kind of networks. You can see the Australia is a very developed country, but the desert parts of the Australia are not very easy to handle, and that's why there are not many stations over that reason. And maintenance is a big issue. For example, once you install a weather station, and then there is a lot of trees and shrubs grow around that, and if there is not a regular maintenance of that, then it will be giving you any reading. Actually, if you see on the left hand side, there was a wrong reading was coming for a station in Italy, and it was showing that it is a very high temperature over that region. But the fact was that station was malfunctioning because of the poor maintenance. So those kind of things one has to take care while taking these observations. And a regular maintenance, a regular upkeep of these instruments is very necessary. Now let us go to the upper atmosphere. The upper atmosphere, going to upper atmosphere, there is one way how we go to the upper atmosphere is basically, there is a standard way to do that. They put some instrument on the balloon and they fly this balloon. And this balloon goes up to the height of 30 kilometers. And it tells you that what is the wind. Actually, on the right hand side, I've showed you some arrows. We show what are the wind blowing at different heights. And this balloon cannot go more than 30 kilometers, because then the pressure becomes very low and it expands and it gets very hot, and ultimately it blasts. So 30 kilometers is a very good height if a balloon can go to 30 kilometer height. So this provides you the temperature, humidity, wind, and solar radiation. Of course, solar radiation at that height is not necessary, but there are so many measurements that this kind of balloon measurements are providing. And you can see that there are approximately 1,000 stations which are operating these balloons. These balloons are, these are very expensive. It is not easy to operate a balloon station. So there are not many people who are doing it. IMD has several stations, I think more than 50 or 40, 45, 50 stations, where they are launching these balloons at least once a day, and in some places they launch at least twice a day. So this balloon observations gives immense information about the weather, because ultimately the weather is driven by the atmosphere that is lying above 1 kilometer, above 2 kilometer, 3 kilometer, because clouds are coming from there. It matters that what is the wind is blowing at the cloud level, what are the freezing levels, how the temperature is dropping as you go up. So this information, without this information, it's very difficult to do a successful weather forecasting. This is a very, very important piece of information. Even in the time of satellites, this information is the key to the forecasting still. Even though the lots of forecasting, lots of observations nowadays we are getting from satellites, but we cannot replace the radio sound observations still. Okay, now what is happening in the oceans? So similar to the atmosphere, we also have the oceans. So oceans also the same, similar to the atmosphere, we have the surface type of observations and the deep sea observations. So you can see that these blue dots are having deep Argo. The yellow circles are having the deep Argo. Then they have the tide gauges. Then they have, so they're also measuring at the surface as well as they're measuring at the deep sea levels. So this is very important because nowadays the forecasting is done by the coupled models which have both the ocean as well as atmospheric forecasting. So people have realized that you cannot do atmospheric forecasting without including the ocean conditions into that, because it is a coupled system. So both are interacting among each other, and it is very important to develop a observing system for the oceans. So this is you can see there are tens of thousands of the buoys spread all across the global oceans, and they are providing very variable measurements for which are basically fed into the ocean models for the prediction of ocean state for the few days, the few months, and few weeks to few months. Now, if you see, even though these are a very good platforms for the making observations, but you can see there are a lot of gaps are there. And maintenance of so many observations, it is a very costly affair, and it is basically a very time-consuming affair. You have to go to these sites to maintain them, and that is not easy. For example, you cannot go to the middle of the Pacific. Once they have installed the instrument there, it is very difficult to maintain it. You cannot go there and check it every day that, okay, what is happening, whether my instrument is in the right state or not. So because of this situation, we needed a platform which can provide the measurements even in a non-maintenance way, and it can provide the global measurements by the same instruments. And the obvious answer to this was the satellites. So these are the satellite. There are two kinds of satellites like this. So you can see that as the Earth rotates, Earth takes one round in 124 hours. So if we put a satellite and the Earth is rotating, then we will not be able to constantly monitor it. So there are two kinds of orbits, and so it is in the left side. You can see that there is one orbit which rotates with the same speed as the Earth's rotation. So for this satellite, actually the Earth looks like a stationary area. So that is why these orbits are called geostationary. The geostationary satellites provide the information, constant information, continuous information of a place. But the thing is that, and there is, but the problem with the geostationary is that they look at one place only. So the geostationary satellite which is placed on India will look only India. It will not be able to look at Australia, or it will not be able to look at Japan or maybe America, etc. But for the weather forecasting, we need observation for the globe. So for that, there is another kind of orbit that's called the polar orbit, which is near to the Earth's surface. Geostationary orbit is 36,000 kilometers, but polar orbits are basically from anywhere from 500 to 800 or 900 kilometers. They are much closer to the Earth, so they give you much clearer view of the Earth atmosphere, and they give more resolution. But they come to one location two times a day only. But the advantage is that they cover the whole globe. So it is going. So in the next round, it will go to the other part of the globe, and in one day they cover the entire globe. So there are two types of orbits in the satellites that we are utilizing. So because of that, so what are the advantages actually of the satellites? Advantage is the coverage. Satellite gives you much more coverage than a classical instrument. Instrument will give you particularly at a location. Then it is repeativity. So it can repeat many times in one day or many times in 1 week. It can repeat many times. And the most advantageous thing is it is representative. What is meaning representative? Representative means it is the same instrument which is taking measurement everywhere. So if there is something wrong with those observations, we have to correct that observation only one time, and all the observations will be corrected. This is called the bias correction, or maybe the calibration of the satellite observations. So you have to correct only once. You have to correct only one instrument, because there is only one instrument on one satellite. So, but if there are 10,000 ground-based instruments like the 10,000 radio sonde or 10,000 AWS, so you don't know, because they are independent of each other. So you don't know whether one is measuring accurately, so other is also measuring the same thing, or whether. So those kind of things are, because each instrument is independent. Here, one instrument is there for the whole world or the whole entire region. So that is the very big advantage of satellite observations. And this was the first time that the satellite observation, when first satellite observations were launched, they were basically a TV camera, which was not even digital. So it was just sending some pictures, some analog pictures which you are seeing in the old black and white pictures. But this gave some idea that how the cloud system, how the global Earth system is moving, how the clouds are moving from one place to another. And then people started realizing that you cannot predict weather just by seeing at one place, because what is affecting the weather at Dehradun may be coming from China, or maybe coming from Pakistan, or maybe coming from Russia. Some winds are coming from Russia and then they are affecting the weather of Dehradun. So you cannot look at Dehradun and then predict the weather of Dehradun. You have to look the entire world for doing those kind of predictions. So that is why we require a large scale observations. And those observations can be provided only by satellites. And in the last many years, the satellites have progressed tremendously they have progressed. So earlier they were just a picture, that television picture. Now they are they went to some multispectral channels, then they started channels, then they become digital. Now digital data was coming, they applied some filters, so now we are getting the infrared, visible, microwave, and ultraviolet regions also we are able to see. They give you every channel gives you very different information. Then there are microwave. With the microwave, the advantage is that you can see the surface of the Earth even in the presence of clouds. It is very advantageous because it can give you the Earth's sea surface temperature, it can give you the soil moisture temperature, soil moisture, it can give you the winds even when clouds are present. So particularly it is very good for the situation for India, where the monsoon time there are a lot of clouds. So if a satellite cannot take measurements in the cloud, then it will be very difficult. We cannot see anything. But now people are going towards the hyperspectral, where they are having several thousand channels in one camera. One camera is taking pictures in 1,000 channels, 10,000, 7,000, 8,000 channels. There are 8,000 images simultaneously produced by a camera. So this is the hyperspectral. And each channel, they are basically the spectral channels. Each channel gives you different information. So if you look at one channel, the cloud will look different. If you look at another channel, the clouds will look very different. And that difference depends upon the cloud liquid water, cloud ice content, how much water is there. So those several channels give a huge amount of information about the atmosphere and weather. So this is how the current generation weather satellite looks like. It has an extreme ultraviolet X-ray radiation sensor, solar ultraviolet imager, magnetometers, lightning mappers. So we are able to see the lightning also from 36,000 kilometers. So those satellites are able to sense where the lightning is taking place, where those lightnings are traveling, which side they are moving. For example, one big thunderstorm is moving from Dehradun towards Haridwar. So this satellite will be able to capture it. Okay, there is some big thunderstorm, lightning event is going towards Haridwar. It will reach Haridwar in next half an hour. So people will be alert from that. And India is also planning this kind of satellite under INSAT 4 series. So probably by 2025, India will be having similar kind of satellite in the orbit. So there are many geostationary and many polar orbiting satellites. There are several, maybe not. Polar satellites must be close to 100, and geostationary maybe 20 or so. And what is the size of nowadays? People are launching very small satellites also, which are around 4 kilograms. There are CubeSats. So they are doing one specific kind of job, like they are measuring the rainfall only. But there are so many, because there is one disadvantage of the polar orbiting, that they visit one place only twice a day. But if we launch so many satellites like that, suppose we launch 10 satellites, then every 2 hours, every 1 hour, we have one observation. So nowadays that idea is coming into people's mind, that why not launch so many satellites? And very, very small satellites. And ISRO, that ISRO has once launched 100 satellites from one shot. So ISRO can easily launch hundreds of such satellites, easily. And then they can provide a lot of coverage. Of course, they can provide the debris. They can create the debris also. So you can see the size comparison of the today's satellites. The Earth observations CubeSats, they are 4 kilograms only, which is the average weight of a watermelon. So some satellites are almost as big as a watermelon, and the big satellites are as big as a truck. So you can see the GOES satellites, which are the geostationary satellites. They are very heavy satellites. Of course, 3,000 kilograms, which is the average weight of a truck. So this range is going from very small to the very large, and they all are basically providing very, very useful information, timely information for the weather. Of course, I have told you about this. This is the geostationary satellite orbit. And this is the kind of things that geostationary satellite is providing. It is looking at the Earth as if these all pictures are shot by the same satellites. So satellite is not moving. So whatever is moving, the clouds are moving, so satellite is tracking those clouds. So for that, if satellite is also moving and the clouds are also moving, then it becomes a complicated problem. So satellite has to be stationary. So that is why the geostationary satellites are very good for monitoring these thunderstorms, tropical cyclones, cloud systems, etc. And it's an extremely useful tool for weather forecasting. No weather agency can work without the help of these geostationary satellites. And what kind of information they are providing? They are providing the winds, fog, sea surface temperature, land surface temperature, so many things they are providing, humidity, outgoing long wave radiation, air quality. Air quality, they are providing it every half an hour, every 15 minutes. So this is very, very important observations they are being provided by the geostationary satellites. And these are the constellation of geostationary satellites. Our INSAT 3D is lying here, you can see on the right-hand side, bottom side. Then there are the Meteosat by the, basically Meteosat is for European agencies. GOES satellite are operated by the American agencies. Himawari, very good satellite in the geostationary, it is operated by Japan. And apart from that, there are so many polar orbiting satellites which are providing very useful measurements. And the ISRO has been doing the development of this kind of satellite for a very, very long time. And there is a series of INSAT series satellites and the Kalpana satellites, and there are two INSAT satellites, INSAT 3D and INSAT 3D-R, which are right now operational, and they are providing useful service to the nation. These are how these satellites take measurements in different spectrums. Of course, most of the spectrum is from visible to infrared and microwave only. And because the gamma ray, ultraviolet, etc., they are used for the outer space, like the solar radiation kind of measurements. So most of the meteorological observations are relying on the infrared, microwave, and infrared to microwave, visible, infrared, microwave. So these things can provide a very, very valuable information. And these are the different observations that are provided by the satellites. They can provide the winds, temperature profile, sea surface temperature, sea surface height, and the vertical profiles of the rainfall, sea surface salinity, rainfall. There are so many parameters. Of course, I have listed very few of them. There are n number of parameters that are provided by the observations. But the thing is that, the observations are not enough for making prediction. These observations are very good. Observations are extremely crucial, extremely important for the prediction. But you cannot make prediction just by taking observations. You can predict for next 1 hour or 2 hours only. That is very short range prediction. Very short range prediction. That is up to 2 hours or 3 hours, 4 hours. And that is called nowcasting. And nowcasting is done by purely observation. There is no direct model. So they take direct observation from satellites or radars, and they make the observation. You can see that if you see this picture, you can probably predict that where this storm is going, and you can predict that, okay, this is going to hit this another city. So these kind of predictions are made based on the satellite images, the radar images itself. There is a lot of work has been done in SAC. Dr. Bipasha is doing a lot of work on the nowcasting by satellite observations. And the right panel is showing some examples that how the satellite observations, satellite images were used to predict the weather. But unfortunately, you cannot go very far. We cannot predict tomorrow's weather based on satellite pictures. For that, you have to have models. And what is the model? Then comes the weather and forecasting models, and it is a very, very important area of weather forecasting. So what is a model? Basically, model is a kind of software. It is software only. You have to install that model. You have to apply that model. You have to do the use of that model. So model is basically there are so many equations. Our total knowledge of the physics and total knowledge of thermodynamics, total knowledge of biosphere, cryosphere, interaction, air-sea interaction, etc. It is all built up into the mathematical equations, and it has put up in the form of a software which can run and which can provide you the weather of tomorrow. But it is a very, very complicated, very complex, one of the most complex softwares on the world, and they are employing the world's biggest computers. The whole computer industry, the most powerful computers are being used for the weather forecasting. Most powerful computers. Even today, I think some few days back, the most powerful computers were installed in India's Tropical Meteorological IITM, and in wherever if you see in the world, the best computers are being employed for the weather forecasting purpose, because there are I think many bit of floating point operations you have to do a successful weather forecasting at a high resolution, and you have to put into account take into account the land surface also and the ocean surface also. So all these things are very important to take into account. So this basically they start with the initial condition. These models are they are like the Newton's second law. So the rate of change of momentum is equivalent to force actually. So basically, if there is a force, you can predict the change. You cannot predict the force itself. You cannot predict the force. You cannot predict the force. You can predict the change in the wind. What is the Newton's second law? The rate of change of momentum is proportional to a force. So if you know the force, you can know how much momentum will change. So, but say if the mass is fixed, then you can know that how much velocity will change. So that forces you should know. So there are many kind of forces like pressure gradient force and the Coriolis force and so many frictional forces. So you have to accurately calculate these forces, and you can predict only change. You cannot predict the absolute state. So if you can predict only change, it means you have to know what is the situation now. Then only you can predict tomorrow, because you can predict the change. So you can add that change and you can predict for tomorrow. So for that, to get the best forecast, you should have the best observation. So you should add the times at time t equal to 0, you should know exactly what is the situation of the weather. So that is why these observations are very, very important. And based on these only, we predict for the climate. We also predict the seasonal forecasting. We also predict for the 5-day forecasting, 10-day forecasting, etc. Every forecasting is done by the same models, but their rules and their assumptions are different. When we predict for 5 days, it is a different assumptions and different rules we are taking. When we predict for maybe 10, 20 days, or maybe 1 month or 10 months or 2 months, we take into account different assumptions. And when we predict for 50 years in advance or 100 years in advance, we take different assumptions. But the basic models, basic equations, they are all the same. And then there is a big part of data simulation, because no matter how good is your software, ultimately your model will never be perfect. So after some time, this model will start drifting from the actual what is happening actually in the atmosphere. So model has its own atmosphere. So model will predict something, but after some time, after 10 hours, some 20 hours, 36 hours, or maybe 72 hours, the what model is predicting and what is actually happening will be slightly different. So this kind of difference is basically, we have to reduce this difference, otherwise our forecast will constantly getting worse and worse. So this kind of errors are reduced by the means of data assimilation. What is data assimilation? We ingest more data. Whatever we are also observing the weather. Once the model is predicting, and we are also observing. So we ingest the model into the observation into the model, and tell the model, okay, this is the right path. You have to follow this right path. So you can see that these are the paths of the blue color is the path that model was taking, and the red color is the correct path. So we have to always bring the model to the correct path. So this is done constantly. Every 6 hours, a lot of data goes into the modeling system. Every 6 hours, new data comes, and this is ingested into the model, and that is how the model are able to predict very accurately. And the model predictions have really improved. Actually, nowadays everybody will agree that the model forecasting has improved very drastically in the last 10 years. If you tell that tomorrow is going to rain at this time, it definitely rains. And if you say that it's not going to rain, then it doesn't rain. So those kind of confidence have built up, and then people have a lot of confidence on weather forecasting methods and weather forecasting practices. Otherwise, earlier times, it was nobody will believe that if you predict some weather. But now, the weather forecasting has gained a drastic credibility. So what is the forecast skill actually? You can see the weather forecast skill is maximum up to 20 days. 20 days is, of course, I'm saying on the higher side. Maximum 8 days. In India, if you say, then being a tropical country, the forecast skill is even less. Actually, if you can predict up to 5-6 days in advance, that is a very good forecast. Then we go for the next seasonal, sub-seasonal forecast. That is good up to 60 days, maybe 2 months. But the sub-seasonal forecasts are depending upon different weather regimes. Actually, some weather regimes is processed. And basically, these forecasts are not exactly pinpointed forecasts. It is not over Ahmedabad. It is over a large region. So we have to average in time and average in space also. So basically, when we say the weather forecast we give what will happen on Ahmedabad at 4 o'clock, or in Dehradun, what will happen at 2 o'clock. So seasonal forecasting is not done like that. Seasonal forecasting will be done what will happen at the state of Uttarakhand. So a scale is larger. And in the month of October or in the month of February. So we are not talking about what particular day. We are not saying that what will happen on 15th February or 20th February. We are saying in the month of February. Then seasonal and climatic forecasting are done. Now, a lot, actually, what are the different assumptions actually depends upon the memory of the atmosphere and memory of the different components of the Earth atmosphere system. So if you say that what is the atmosphere, the memory of the atmosphere, the memory of the atmosphere is very short actually. It is 1 to 7 days only. So what is happening today, after 7 days, there is no correlation with that. So today it may be very hot, but tomorrow or 2 days later, it may be very cold. So the atmosphere has a very short memory actually. Atmosphere, you cannot rely. Today is cold, so 10 days later also it will be cold. Okay, we cannot make that kind of statement. So if the atmosphere memory is short, then what we can do? So we have to rely on other factors. Then land memory has a better memory than the atmosphere. So if the land is warm or land is cold, if the land is having wetness, land is having a lot of wetness into that, so it will persist for quite some time. So it can persist for a few weeks. It will not that today there's a lot of rainfall and the land has become very wet. So tomorrow suddenly it will become dry. It will take some time to become dry. So that leads to its memory. Then we have the upper ocean. We have the memory from weeks to few months. And if you go to the deeper atmosphere have several years. So if you know the deeper, that's why people are making lots of effort to understand what is happening in the deep oceans. Because deep ocean memory is very, very large. So if you understand that and if you can predict it, so you can predict maybe several years in advance that which years are going to be much hotter and which years are going to be much colder. So for example, this is the El Nino cycle, ENSO cycle. You can see the very important phenomena of the ocean, and it occurs at every 4 to 5 years. You can see that once the ocean is cold or warm, it remains warm for quite some time. So it doesn't suddenly becomes cold. So it actually manifests. This shows the memory of the ocean. You can see the date. What is date is running. So it runs for a few months. Actually, it remains for a few months. And if you see the large currents like the Great Conveyor Belt circulation, that is the global ocean current circulation. You know the time period of this circulation. Actually, there is a current that goes up. That goes to the very high latitude near the poles, near the Arctic Circle, and then it dips because it becomes very cold, and it dips and then goes underground and underwater, and then makes a complete circle. And this circle takes 500 years to complete. So if you can understand by correct observation and the right amount of the observation network, if you can understand this phenomena, then probably we will be in a much better position to predict it also. As we have earlier mentioned that the basic key to prediction is to observe some phenomena and to understand that. And many agencies of the world and India's the Ministry of Sciences, they are putting a lot of effort and ISRO also putting a lot of effort to understand the deep ocean and the what are the different oceanic processes, because the understanding ocean is the key to predicting weather successfully. And if you can understand the deep oceanic processes, if you can predict those processes very accurately, we can predict probably 1 or few years in advance also. Now, this is my last slide actually. So how we can predict the climate 50 years or 100 years in advance actually? This is a very genuine question that how we predict it. So these kind of predictions are made under some scenarios. We have to take a scenario. For example, you know that everybody knows that the global warming is taking place. We know that the global warming takes place due to the elevated emission of the carbon dioxide and the other gases, which are basically trapping the radiation and leading to the global warming situations. So we assume some scenario with that. So basically, what we assume that, okay, let us assume that the global warming emission will remain as it is. So what will happen due to that? So you can see the topmost curve. So then the emissions will increase several degrees and then we can have a 5-degree warming. Then under 5-degree warming, what can happen? What kind of situation can occur? How the circulation will change? How the winds will change? How the vegetations will change? How the ocean will change? How the melting will occur? So those kind of scenario is simulated by the model. So again, we use the same mathematical equations and then simulate 1 year, 2 year, 3 year, and then we take mostly yearly averages, monthly averages. We are not using daily average for that. We can't tell that this will happen on 21st October to 2090. Those kind of things cannot be predicted. But we can predict the average state of the Earth on that year. So that's why these kind of predictions are good only for the yearly average basis, or even more. And there are many scenarios, some scenarios are there where they say that after a certain time, this governments will take some action and they will do something to reduce the emission. So after a certain time, for example, after 2040, the emission will start reducing. So at the end of 2100, we will have a very less warming or even less warming than even today. So then the climate will evolve very differently in this situation. And like that, we have different scenarios. So actually, lots of decisions people make based on this kind of predictions. For example, as I told in the very beginning that this climate change is not only causing concerns, but it is creating a lot of big opportunities for us. So some of the regions suddenly become very good for agriculture because the rainfall has increased over that region. So people, before making investment decision, people want to know what will happen after 25 years, what will happen after 10 years, what will happen after 40 years, because they take a very long-term scenario for that. So suddenly some regions, for example, some regions of Africa or some regions of other continents will become dry. There will be increased desertifications over that region due to so much warming. Some regions will become suddenly dry. So in today's time, they are doing a very good agriculture, but maybe tomorrow or maybe after 40 years, it will not be suitable for agriculture. And you cannot depend too much upon your groundwater irrigation type of system because they have some limitation. They cannot last forever. So they have to, rainfall is going to remain a major source of water because ultimately the rivers and the groundwater will also come from the rainfall only. So the precipitation projections are very, very important for these scenarios. So this kind of climate changes are done through the model and the simulations under different radiation and different temperature increase scenarios. And once we know the temperature increase, then we can know everything because everything is coupled. The thermodynamics is coupled to the dynamics. Dynamics is coupled to the this thing. Hydrospace is coupled to the cryosphere. Cryosphere is coupled to the biosphere. Everything is coupled. So these kind of all the processes, they are modeled. They are the softwares are made for that into the model, and all these things are simulated for a very long time, like maybe 100 years or maybe 120 years. And these kind of simulations give a lot of insight to the different governments that what kind of actions are to be taken. If you don't take any action, then what kind of things can happen and what kind of catastrophic situations can arise. So these models and these observations which are coming from satellites are extremely important for our society, our system, and our existence also. And with that, I convey my lots of thanks to you for listening carefully my talk. And with this, my talk has come to an end. Thank you very much.
Yeah, thank you very much, sir, for an extremely informative talk. Sir, we have got a lot of questions. So with your permission, we can take few questions from participants.
I'm not able to see those questions actually. If you can tell me, then I will be able to answer those questions.
Yeah, sir. Yes, sir. I will just speak the question. So the most frequent question is, what is difference between weather and climate?
Yeah, actually weather and climate, the difference is weather is day-to-day situation. Climate is average state. For example, the climate of climate of your place, maybe suppose it is a dry place, or maybe it is a humid place, or maybe it is a cold place. Like Dehradun is a cold place, but Dehradun can be warm on certain days. Dehradun can be very hot on few days. So on those few days, it's the weather actually. And what is the general situation, average situation, what do we expect from Dehradun. Once we go to Dehradun, then what do we expect? We expect that it will be very cold. Or we expect once we go to Mussoorie, we expect that it will be cold. It is climate. Our expectation is climate. Because we take the long-term average of the weather. And what is happening on the day-to-day basis is the weather.
Yeah. And so the next question is, how accurately a satellite can predict weather and climate?
Actually, satellites do not predict weather. As I mentioned in the very beginning, satellites can be good for the nowcasting. But ultimately, the weather and the climate prediction is to be done by the models, which are sophisticated mathematical models, which has to be employed. With the observations, you cannot predict more than few hours or maybe 1 day or 2 days you can predict, not more than that.
Yeah. And so next is, how do we predict weather and what are the parameters used for the purpose?
How do we predict weather?
Weather, yeah.
Yeah. Actually, weather prediction is done on many scales. For example, from the very short-term scale, that is called the nowcasting, and very useful time scale for the weather prediction. That is from 0 to 2 hours. And it is extremely important scale. For example, many people like the aircraft industries, the aviation, launch purpose, they use this window, 2 hours window. This nowcasting, it is done purely based on satellite observation. So you just extrapolate or maybe do some very intelligent machine learning or maybe artificial intelligence methods. Use only satellite data, satellite images and predict in future. But that's what I told you. This is limited to 2 hours only. 2 hours or 3 hours, 6 hours, 4 hours, few hours only. If you have to go to few days of prediction, you have to use the models. For that, you have to use temperature profiles, humidity profiles, sea level pressure, surface pressure, basically. Then you have to know the winds. You have to know the only I think these 5-6 parameters you have to know.
Okay, sir. And the next is how to protect against global warming.
Yeah, actually, this is a very good question. It is a very important question that is concerning many governments and many societies and many active groups in the climate science. So, and the basic reason for the global warming is basically the carbon dioxide emission. And in some way, so far this is good. Actually, this is actually helpful because if you see climatologically, the Earth would have been extremely cold by this time if this global warming was not there. But after a certain point, this will become extremely problematic. And this global warming can be reduced by reducing the emission, by burning less fossil fuel, by emitting less carbon dioxide into the atmosphere, by cutting less, by planting more trees, by cutting less forest, like that. These are the measures. But and actually, these measures, once you have to develop something, you have to go for some kind of deforestation. So with the development, certain amount of carbon dioxide increase will definitely take place. But people have to see what kind of other measures are there which can be taken so that we do not emit so much carbon dioxide, or we go for the forestation, plantation, so that whatever we are removing from the earth, we have to actually give it back to the earth, so that we keep the balance.
Right, sir. And sir, the next question is, why can't we do 100% perfect forecasting?
We cannot do perfect forecasting because, first of all, observations are not perfect. Even if you measure from the very high quality instrument, you will never know what was the actual wind. Truth is never known to anybody. What was the actual wind? Your instrument is measuring something. So always there is error in every measurement. There is error. Some instrument measure very accurately. Their errors is very less. Some instrument not measure with so much accuracy. But no matter which instrument you use, there is bound to be some uncertainty and some error in that. Number one. Number two, our models are also not perfect. So our understanding about the processes of this weather are not yet 100% perfect. It is not 100% perfect. And even if it is perfect, both the things are perfect. Even then, it is not possible to predict the weather forecasting precisely for more than maybe some 15-20 days, because that is the theoretical limit of predictability. Then lots of nonlinear dynamics comes into picture, and chaos. chaos theory, the butterfly effect, all these things comes into picture, and then after a certain time, certain limit of time, you cannot really predict the weather very accurately.
Okay. So next question is it true that because of global warming, the animals are being affected on large scale?
Definitely affected. Definitely they are being affected. They are affected in many ways. Many species has become extinct because they could not cope up with the global warming. There are means, for example, if you take the urbanization, suppose there is a highway and some small animal used to cross for their annual migration. Now they are not able to cross it because the animals normally migrate in the winter time. They migrate to the south. Summertime they migrate to the north, and they have been doing it for the last many millions of the years. Now suddenly we build up something, and then some large animals, of course we take care always. We make some corridors for elephants and this thing, but many small insects and many small animals, they simply cannot cope up with this kind of development situation and the global warming, and they become extinct. So this kind of extinction has taken place, and it is happening every day. So every day some species is getting extinct due to this global warming and this development.
Okay. And so what are the basis for giving a name to a cyclone?
Actually, the name of the cyclones in the Indian Ocean region is given combinedly by many countries. So they represent in World Meteorological Organizations, and there are several countries like Pakistan, India, Bhutan, like Myanmar, Sri Lanka, like that. All the regions, all the countries in the Indian Ocean region, they have a combined forum in the WMO, and then they decide these names well in advance. So what is the next cyclone? Whatever next cyclone is going to come, its name is decided already, or even the next cyclone, its name is already decided. So these names are decided for next year. Also, the names have been decided already. So every country gives few names, and they select from those names. So that is why you sometimes find the names of the cyclones which you cannot understand because they are given by some other country.
Yes. And so next question is there any technology to check how much water is absorbed in Earth during rain season?
Yes, to a limited extent, you can predict it. For example, if you are interested in first 10 centimeter of the Earth, so you can know it from the like synthetic aperture radar microwave measurements. So microwave is quite good in giving the first 10 centimeter or first 6 centimeters of the absorption of the water. So soil moisture in the first 10 centimeter can be known by microwave active and passive microwave instruments. But if you want to go much deeper, suppose you want to know how much water is there in maybe 70 meters below or 10 meters below, then these microwave measurements will not be useful. Then you have to use a different technique for that. That is called the Gravity Anomaly. So there is a GRACE satellite, that is called the Gravity Anomaly Recovery Climate Experiment, something like that. So that GRACE, they measure, those satellites are in the orbit, and they, according to the gravity, they slightly shift their orbits. And each satellite is following another satellite through a laser beam. So they can measure these precise changes in the orbit, and they can find out what is the exact gravity at that location. So, the water is very heavy substance. So if there is a lot of water in some soil, so it becomes heavier compared to last year. So these gravity changes can detect that water. So this is called the liquid equivalent water mass anomaly, which is detected by these gravity anomalies. So they are done at large scale and very deeper scale.
Okay. So the next question is, why do rain comes mainly in afternoon?
Yeah, actually, afternoon, there is a diurnal cycle of the rain. Afternoon, in the morning, what happens that there is a lot of moisture near the ground. Okay, and what happens that, in the morning, everything is a stable condition because land is very cold. So once the bottom part is cold, it is good. So everything remains near the ground. It is stable. Now once slowly with the heat, with the heat of the sun, the ground started becoming warm, and then slowly the water vapor and water vapor rises up in the atmosphere. And if the atmosphere is dry in the maybe suppose 5 kilometers above if the atmosphere is dry, then they shoot up like anything and they become thunderstorms. And particularly in the slopey regions like Dehradun and Mussoorie, etc., this can be even more unpredictable because the slopes, how the slopes radiation, how the sunlights are acting on the slopes and how they are radiating, how much water is available in the plants and how much it is contributing to the storms. It is very complex and difficult to predict.
Okay. And the sir, next question is, what should be done to clean ocean?
To?
Clean ocean.
Clean.
What can be done? Yeah, clean ocean. Yeah.
Actually, only technology can help because we have polluted the atmosphere and the oceans in last many years in such a drastic manner that it cannot be done even if we stop using all the plastics. Suppose you don't throw the plastic, you make the proper management of plastic, because the biggest one of the major cause of concern is the plastic pollution, because the small rubber bands, the small toothbrushes, small this thing, small loops, small bottles, this becomes a big headache for the many animals, because they get stuck up into that and they cannot come out of that. And then this pollution is harming the wildlife into the oceans in a very, very bad way. So what we can do is basically to reduce the use of pollution, the plastics, and before throwing them, use some degradable material. The plastic is not a degradable material, so if you can use that way, we can contribute to the cleaning of the oceans. But there is some technologies coming to how to clean the ocean. They can filter some parts of the ocean, but it is very small. If you see the size of the oceans, how vast it is, these efforts are small. They are meaningful efforts, but they are small efforts. We will take a long time to clean the oceans completely. But definitely some people, some groups, they are using some technology. There are, like the drifter robots are there. So there are drifter robots, they go on their own, they take a round of the ocean, nearby coast, and they clean. They take a net with them and they collect all the garbage with them, and they come to the shore. Then there are some other filtering methods are there. So they put a lot of funnel, big funnel, and everything is stuck in that funnel. So those things people are applying, and a lot of good voluntary organizations, they are doing a lot of things to clean the atmosphere. They're environmental groups. So they're doing, but the harm that has been done is much bigger than these efforts. So I hope in future people will be more aware of all those things.
Yeah. So the next question is, what is meant by geostationary satellites?
Actually, geostationary satellite is actually, if you place a satellite in the orbit, it moves with the different velocities. So if you put something very close, if you move very fast, so if you put something at 36,000 kilometers, it will take the orbit of the Earth in exactly 24 hours. So it is rotating at 24 hours. Earth is also rotating at 24 hours. So it is, for anybody in the Earth, it will appear as if the satellite is fixed. So Earth will look stationary for him. So that is why it is called geostationary. So its orbit is around 36,400 kilometers, and its rotation time is 24 hours.
So next question is, can we say that climate change is due to global warming?
No. Climate change can occur due to many things. Climate change has been occurring many years even when humans were not there on the Earth. So climate change has been occurring for several hundreds and millions of the years. So climate change will happen even if humans are gone from the Earth. Then also climate change will happen. Because there are so many factors, like as I told you, something is happening within the Earth. Like some big volcano is going to erupt. Suppose tomorrow a big volcano erupts. Then it will cool the Earth so much within 1 month that there will be no global warming after that. So there are big forces already. So human forces are much smaller compared to that. So they occur once in 10,000 years, once in 5,000 years, and they play a very big role in that. So climate change happens because of changes in solar position, changes in Earth's orbit, changes in Earth's inclination, then changes in ocean conditions, changes in deep ocean surfaces. So there are many things which are non-human, so which are leading to climate change. But currently the largest signal of climate change is coming for the human activity only for the last 20-30 years. But 30 years is a very small period. Suppose last 100 years maybe. But that 100 years is a very small time period if you consider the complete epoch of the climate cycle.
So And so next question is, if the polar ice cap melts, then the sea level will increase. Will it affect human beings?
It will affect human beings in many island countries, small island countries. There are many islands which are where humans are staying, and there are very, very small countries. So those people will be affected. India will not be affected so much, but some part of India will be submerged, but it will not be affected that much. But some parts of Bangladesh, some parts of maybe like Andaman or maybe some small island countries will be affected in a very, and those small island countries are very poor countries also. So they don't have resources to fight those climate change. They cannot make a big wall around their country and then stop it. So those kind of things is not within their reach. So basically climate change is created by the rich countries, or it is basically affecting the poor countries. Actually, that is the situation.
And so next question is, if temperature increases massively, what will happen?
If temperature increases, then many things can happen. For many of the ocean creatures will become extinct, like that. May happen.
So one question is related to the balloon observations. Like, what happens to balloon once they serve their purpose?
Actually, this balloon gets exploded. Balloon explodes, and it gets lost. And that instrument is, it comes to ground with a big force, and probably many of them get damaged. If some of them not get damaged, then they return it to. Then they call those centers, and then they say, "Sir, I have got your instrument. What should I do?" But I think they are not of much use.
So, do earthquakes occur due to change in climate?
Actually, climate change occurs due to earthquakes. Earthquake is a big force. Earthquake is a much bigger force compared to what this small temperature change we are talking about.
Right. And so, can global warming be controlled?
Yes, I told you, basically, if we have the emission, if we tell in this graph, you can see this violet color graph. This is basically the experiment when we assume that everything will be controlled after 2020. So some governments are taking measures. Some governments are taking extreme measures. Like several European countries are taking extreme measures for controlling and keeping the climate change in control.
So what happened to satellite once it finished its life?
Actually, satellite, once it finishes its life, it remains in the orbit for quite some time. Then slowly, basically, every day, satellite experiences a lot of, what is that called? Drag. Because there are a lot of particles in the atmosphere. So many ionized particles are there, so much, even molecules are there. And because of that, there is a friction between satellite and there is not, absolutely vacuum is not there in the atmosphere, in the space. So there is a drag. And drag is also occurring because of the moon forces. Moon is also pulling the satellite. Different planets are also pulling, like the Jupiter is also pulling, Sun is also pulling. These are small, but ultimately they are creating a drag into the orbit. So every day a thruster is fired to keep the satellite into the orbit. So it is just like a spray can, just like a spray can. So it is enough to put the satellite, to tilt the satellite to keep in its orbit. After some time, this fuel is all the liquid in this spray can is lost. It is gone. Then there is nothing we can do to stop the satellite from drifting. So it drifts slowly towards the Earth. And ultimately, it enters the Earth's atmosphere again, where it burns. 90% time, 99% time it burns into the ashes. But even then, if there are some fragments of that remains, they most probably they lie down and they go into the sea.
Yes, sir. And so next question is, what can be done for space debris?
Actually, space debris, right now there is no solution for space debris, and it is increasing day by day. But some people are thinking of making special satellites with robots who can collect the space debris, bring it to the Earth and destroy it.
Yes, sir. So then why rainfall is continuously changing in India?
Rainfall is changing because of these climate changes. Global warming, climate change, deforestation, urbanization, all these factors are responsible for changing. These are the human factors, but apart from that, there may be some climatic factors which are natural factors, which we do not know. So those studies are being done still.
Yes. So there are actually many more questions, but I request participants to directly approach Dr. C.M. Kishtwal on his email address for further queries, relevant queries. The email address of Dr. Kishtwal is chandrakishtwal@gmail.com. Thank you, sir. Now I request Dr.
Pooja ma'am, just a minute, because so many students have joined us. So I request Dr. Harish Karnatak to kindly say a few words about the e-learning and the EduSat contents that we have online for the benefit of all the students. So I request Dr. Harish Karnatak.
Yeah, thank you, Aspa. As you told that many questions are coming regarding the online contents. IRS is hosting a website called elearning.irs.gov.in. So the participants those are interested on the basic concept and advanced concept of remote sensing technology, GIS and applications, they can visit this website and they can register without any cost. So freely courses are available. And all the contents we have hosted there as a e-learning content, plus the video contents also we are hosting in the YouTube channel of IIRS, where they can directly get access to these contents. So if they are interested on these courses, they can also join all the online courses are freely available for the students. And we are announcing the different type of courses every year. Basically in the month of January, we'll be announcing a new course calendar. I request all the students to just see the course calendar, and based on their choice and interest, they can register in the programs and they can join our courses. Thank you very much for this information.
Thank you so much, sir. Over to you, Pooja ma'am.
Yeah, thank you, sir. Thank you, Aspa. Now I request Dr. Prakash Chauhan, Director IRS, for his address. Sir. I request Dr. Prakash Chauhan for his address, Director IRS.
Thank you, Dr. Kishtwal, for giving a wonderful talk and also answering the questions of our participants. I hope that this session must be very useful to all the participants, and we all give big claps to Dr. Kishtwal for his very nice and very informative presentation. Thanks from my side.
Thank you.
Thank you, sir.
Thank you, sir.
Now, being Treasurer IMS-DC, I take honor to propose a formal vote of thanks. It is our pleasure to have heard Dr. C.M. Kishtwal. We are extremely thankful to him for accepting our invitation and a highly informative talk. I am sure that the students must have been greatly benefited by his vast knowledge and experience on the subject. I extend heartfelt thanks to Dr. Prakash Chauhan, Director IIRS, ST and Chairman ISRC-DC for his guidance and incessant support in organizing the event. I sincerely thank Dr. Bikram Singh, Chairman IMS-DC and Director IMD Dehradun for his constant support, guidance and encouragement. I would also like to thank Dr. Arijit Roy for playing an instrumental role in popularizing the talk through his contacts. Special thanks are also due to Dr. Harish Karnatak, Dr. Poonam Tiwari and the entire team of EduSec IIRS for their efforts to host their talk online. Thanks are due to entire team of IMS-DC and ISRS-DC Executive Council, especially Dr. Sanjeev Kimoti, Dr. Shama Gupta, Ms. Asfa Siddiqui and Mr. Justin George for their untiring support in organizing this event. I would also like to thank the principals and coordinators from various schools and colleges to motivate the students for participations. Last but not the least, I thank all the participants. Please do not forget to join us on online talk on December 10, 2020. Thank you one and all. Thanks a lot.
Thank you. Thank you.
Thank you.
Thank you.